Hello, everyone, and welcome to this presentation on regulatory benchmarking. So here are the slides, and here's the overview of the 4 parts. So I'll start first with an overview of regulatory benchmarking, and then give you a little bit more insights into what kind of regulations can you have and what kind of benchmarking techniques is commonly used. So let's start by talking about regulation. So if you have a natural monopoly, like a water network, an electricity network, a gas network, or something like that, they are natural monopolies. It will make little sense to have 2 parallel electrical systems network running. The other issue is that there's no near substitute services. So electricity is hard to substitute. Water in particular, it's really hard to substitute with anything else. And it also involves a lot of high cost to install these networks. So there's high economic barriers to market entry. And all of these things means that these networks in all countries constitute natural monopolies, which has the consequence that they are not subject to any kind of competition on the market. And one might therefore fear that there's too high cost and prices and maybe too low quality of supply. The way that this is addressed in many countries is by introducing some kind of pseudo competition on the market. But you don't really compete with another firm operating at the same market. Instead, what you do is that you compete with other firms via a benchmarking model of sorts. You could also organize yourself in another way. You could organize competition for the market. So basically have an auction every 5 years, 10 years to decide which company should supply electricity in a given area, for example. So that's another way to do it. I'll return a little bit to that, but if in practical context, having these repeated auctions is really complicated because it's hard to take over the network designed by someone else. There's a lot of asymmetric information in such a transfer. So let's go to the next slide just to illustrate what we're talking about. So in these regulatory settings, what happens is that the regulator normally works as a proxy buyer of services. So the operator of a network supplies some services to their customers, or we can say they supply some services here to the regulator, and as payment for that, he offers, or he put up a contract beforehand saying that if you supplied so and so, I will pay you this amount RY. The problem for the regulator is that he doesn't really know the cost structure of the operator, and he doesn't really know how much effort the operator put into operating efficiently, or maybe he doesn't really know how skillful the operator is. So there's this asymmetric information, which is really the core of the economic problem. And what the regulator then does is to try to control his behavior by manipulating the payments that he gives him. Normally he doesn't give them directly. He basically gives him, the companies, the natural monopolies, he gives them a right to charge the consumers a certain amount of money. Now, in reality, it's a little bit more complicated than just the regulator-operator relationship, because it's not the political system. They decide on what kind of regulations the regulator should use. Then the regulator fills out the details and tells those to the operator. And maybe the operator is not satisfied with the decisions of the regulator. And then he can then appeal to a court system. And the courts will then decide whether it's a fair amount of money that the firms were allowed to charge the consumers. So it's much more complicated than just a relationship between 2 parties. But the basic problem facing any regulator is actually quite simple to understand. And we can do that with our classical picture of a cost function. So assume that you have on the x-axis, the horizontal axis, you have some outputs. Could, for example, be kilometers of network, or the installed power, or the number of customers that you serve, or the peak capacity, sort of measures of the outputs of these network companies. And then on the y-axis, the vertical axis, you have the cost. And if you have now the cost function as this curve here, moving up, cost function now, and you have a given firm, a given operator, and you can see that he has cost above what is reasonable or what is minimal cost given his level of service here. So he's above the line, and that means that there's some kind of incumbent inefficiency in that company. This company is not operating efficiently. So the regulator's task is to somehow reduce his allowed revenue so that his cost is pushed down to this line here. So that's his first challenge, to get rid of this incumbent inefficiency. But there's another challenge, and that is to get rid of, or to take into account that over time, the frontier is going to shift. We're going to most likely see some technological progress, and therefore the cost of providing given services should ideally fall. So instead of being up here, we should over time maybe be able to move all the way down here. So the regulator also wants to make sure that, that this frontier shift is taken into account. How does the regulator do this? Well, first of all, he tries to get an idea about where this, what this cost function look like, and also an idea about how this cost function is moving. And the techniques he used for that are the techniques that we have discussed in other presentations. So they are basically the state-of-the-art benchmarking methods. A lot of countries are using these methods, and they're using mainly data envelopment analysis or stochastic frontier analysis. This one being an econometric approach, and the other one, the DEA, being a mathematical programming approach. So this is just sort of ways that you can go from actual observation of service cost combinations of firms into a model that describes the relationships between cost and services. So these are the methods that are typically used. And then a typical scheme might look like this. Here I'm illustrating a revenue cap scheme. So what you see is that the regulator might collect some data on 2018 performance. And we are looking here at the total bar is the total controllable costs. So the cost that we believe that the firms could impact in maybe a 5-year period. And what we have identified is that there's this red part of the bar, that's the incumbent inefficiency. So right now, my company is having too high costs. And the idea, the objective of the regulator is to get rid of this incumbent inefficiency. So he's going to do some analysis of this situation, and then he's going to announce, maybe in 2019, he's going to announce what is going to happen. And then 2020 and the subsequent years, he's going to reduce the allowed revenue. So he's asking the firm, is basically requiring the firm to get rid of this cost, controllable cost, and then a little bit more in the next year, and the third year, and the fourth year. So gradually, maybe in a 4-year time horizon, he's going to remove this incumbent inefficiency that he could identify in 2018. At the same time, as we showed in the previous illustration, we also believe that there's going to be a technological progress. So even the best is going to be able to do it cheaper and cheaper. And therefore, you might also just cut like 1 or 2% here at the bottom here. So after these 4 years, you are not allowed to have this full, the same amount of controllable cost. Now you only have this blue area here left. I'm just going to change the lighting a little bit, just a second. Okay, so if you look around Europe, you'll see that a large number of countries are using the revenue cap scheme as the one I just illustrated, but they're also using the techniques we've talked briefly about, like DEA, corrected ordinary least square, SFA. So it's these techniques are actually benchmarking techniques. These modern benchmarking techniques, frontier-based, model-based techniques, are actually quite widely used. You might be wondering whether all of this has any impact, and that's a little bit harder to prove. But as an illustration of some of the impacts these regulations might have had, we can look at the labor use, the labor intensity in Norwegian distribution and regional transmission companies in the period 1994 to 2003. You need to know that in Norway, a more high-powered regulation was introduced in 94. So this is like the start of the new regulatory regimes. And then there was a change in 97, where in the beginning it was like just a general requirement that everyone should save a certain amount per year. And then there was both a general, from 97, there was both a general and an individual requirement, as stated down here. And you can actually see how the man years working in this sector has been dropping a lot in this period. Whether it is directly due to regulation, of course, we don't know, but at least we see a drop. And I can tell you also that the regulation was adjusted once again in 2007, where they moved to a DEA-based Yardstick regime, which is in some sense even more high-powered. So there seems to be some gains from regulation at least. Let me tell you a little bit more about these alternative regulations you can use, and then a little bit more also about the techniques, and then we'll take a break and have time for some questions. There's a lot of different tools in the toolbox of the regulator. He can use many different regulatory frameworks. I've listed some of them here. The traditional one is a cost plus, where the companies just operate and they're allowed to cover their costs. So it's like a zero profit condition they're operating under, or normal profit condition they're operating under. But that gives you absolutely no incentives to reduce cost, because any extra cost you have can just be reimbursed. So then there's a light-handed regulation, then there's revenue cap regulation, the most popular one. Then there's yardstick competition. You can use concession auctions, and then there are also some more sort of fancy regulations you can use, like menu-based, constraint bargaining, and dialogue-based regulations. And I'll discuss them just a little bit, but the main focus is going to be on the benchmarking aspect. So it's not going to be a long and detailed presentation of benchmarking techniques. Just to illustrate, the first project we were involved in terms of regulation was actually in Sweden back in 2000, yes. And the idea was that they just wanted to have a benchmarking study of the electrical distribution companies. And then the logic of the regulator was that just having these performance evaluations, like is indicated in a table down here, where you see, for example, some firms here have 100% efficient, some we evaluated to be 95, and somewhere in the 90% efficient. There's a lot more companies than you see here. There's some 200 and some companies in this sample, but then you also had some red companies. And the idea of the regulator was that he just wanted to identify those that performed the worst, and then maybe he will take a closer look at those. He would also publicize this ranking or these efficiency scores, and then hope for the local politicians or local stakeholders in these various companies to try to put some pressure on these various networks. So that was the idea of the Swedish so-called light-handed regulation. The most common one, regulation which is in use right now, is what we call an ex ante CPI minus X minus XI scheme. The idea here is that you basically analyze your costs and the incumbent inefficiency, as I illustrated, showed you before, and then you make like a 5-year or 4-year agreement with the companies where you tell them how they have to reduce their cost year by year. So the formula could look like this in real terms. You have the cost at time 0. And then in the next period, you have to reduce it with the general X factor, which is like the frontier shift, also the requirement you impose evenly on all companies, and then minus XI, which is a reflection of the individual inefficiency. So you basically reduce the allowed cost year by year based on an ex-ante evaluation of the inefficiencies, and you make like an ex-ante contract about what the allowed income should look like over those coming years. And that is what leads to the picture that I have already explained previously. So that's the idea of the revenue cap scheme. It's very, very popular, and it's, as I said, the most widely used scheme, but it does have some problems, both in theory and in practice. The big challenge is that if you set these general productivity requirements very high, you run the risk of forcing some company into bankruptcy. But if you set it too low, basically, that is sort of the requirement that we impose ex ante on the next 4 or 5 years development. So if there is a lot of technological progress, or there's a lot of possibilities to operate your company more efficiently, then you can end up having companies that make excessive rents and have extraordinarily high profit, which is also not good for the regulator, because it kind of indicates that he has not been up to his task. There's also some problem called the ratchet effect when you update. So when you go from one regulation period to the next, one can actually show that it might be a good idea to add a little bit of extra cost towards the end of a regulation period, because that will determine the starting point of the next. So the next period. So the way I normally often explain it is that if you have to go on a diet, it might be easier if you just gain a little bit of weight before going on that diet. So there is some perverse incentives there, and one can actually see some of that in the data, that it does impact the behavior of some companies. In addition, the picture I showed you were in real terms, but in reality, you have to, of course, to correct for inflation and stuff like that, and it's not obvious exactly which price index to use. It could be a consumer price index, but that also comes with some problem, because then X is not really the frontier shift. It's the question of how much faster does the frontier and the regulated industry move compared to a normal competitive industry. It's not often misunderstood as general X is just a frontier shift, but if you then also have a price adjustment, since the competitive industries are subject to competition, the question is, and that is reflected in the prices, because the competition will keep the prices down. So if you just use a price index from a competitive industry, then what is supposed to be accounted for by the general X factor is only the extra productivity gains in the regulated sector. But that's sort of another aspect of this whole discussion. Another issue that will come up in regulation like this is that if people now are starting to do a lot of new things and a lot of other things, that these kind of ex-ante regulations will easily be challenged, because you have to introduce extra payment for extra new services and stuff like that. So one of the solutions to this is actually to move to a Yardstick scheme, which is like an exposed revenue cap scheme. So you basically let the companies operate, and then you see how much cost they've been spending and what kind of services they've been spending. And then you take, at the end of year 1 here, you do an analysis of all the companies, and you find out what is the minimal cost of providing given services in that year. And that becomes now the allowed revenue for that year. Now, they might already have charged the consumer in that year, but that might mean that they might have overcharged or undercharged, and then you can put that on a regulatory account, and then you have to reduce the charges in the years to come. So that's what is called a Yardstick scheme, made popular originally by, not in regulation, but in general as an incentive scheme by Schleifer, who sort of assumed that you could, for example, use the average cost of all the firms. You could, of course, also, as I indicated, instead of using the average, you could also use the minimal cost. And in any case, you need to correct for the fact that most companies don't produce exactly the same outputs. So that's another way of doing the regulation, where you set the allowed revenue ex post rather than ex ante. The final one, sort of general one I wanted just to mention, is this concession auction. You could basically ask the companies, what would you charge the consumers if you were to supply these services in the next 5 years? And then you can basically just choose the provider that offers the lowest charges, that offers in the cheapest possible way. So instead of having competition on the market between different companies that are doing exactly the same, you now just compete for the market, who has to be on the market. That's what you become. You get a competition for that. The problem with that is that the incumbent, the already existing network operator, has superior information about the cost of operating in this area, the quality of the installation and so on. And therefore it's hard to make a transfer of the assets from the incumbent to a potential new winner of this auction. So that's why it has not really been used at a big scale. It is used in Brazil, for example, when it comes to production and who is allowed to produce water, to operate certain water power, some water-based power plants. So there are some situations in some countries where it is being used, but it is not widely used. I want to mention just briefly that instead of having just one regulation, one formula, like the one I showed for the revenue cap formula, one formula that everyone has to fit into, there's no reason why it should be like that. You could also offer like a menu of formulas that the companies can choose from. From an agency point of view, you can actually show that that can be a really smart way to do it. And in reality, we do see a little bit of that, but not too much. We see it in, for example, Norway and Germany, where you make a model where you have one way of measuring capital and another way of measuring capital. They don't do that in Norway anymore, but they used to do that. But in Germany, they definitely do it. So you have you can measure capital expenses in one way or another way, and then you basically do a model with both ways of doing it. And then if you were to ask a company which one do you want, of course they want to use the one that puts them in the best possible light. So the regulator can actually foresee how the companies which menu choices they will make, and therefore you then use the best of these two results as the basis for the regulation. In Germany, they actually go this one step further, because you can also do a benchmark model based on SFA or based on DEA. And what they do in Germany is that they do both the DEA and SFA model, and they do both of these models, both on these standardized capital expenses and normal capital expenses. And then in this way, you basically get 4 different models that the companies can choose from, but you can predict which one they want to choose, because they want to choose the one that gives them the best possible score. So in this sense, it is a menu, but it's kind of obvious how the companies would choose from this menu. In Germany, there also used to be like a condition that some of the smaller companies, they can just accept a certain reduction of cost and then avoid being part of the benchmarking studies. Another illustration of this menu of contract is that you can imagine here that you have you can provide some quality. Maybe the water can be cleaner or less clean, or it can be some other quality dimension. And then if you have one company with a cost function C1 here and another one with a cost subscript 2 here, then if you were to find the optimal cost quality level, then for company in area 1, which is operated by company number 1, the largest difference between the benefits and the cost is at this level here. So this is the optimal quality level for DSO1, and the other DSO2 should actually operate at a higher quality level. In region 2, you should have a higher quality level. So if one could, in principle, allow that kind of quality differentiation, but one has to be careful, because if you, for example, say that, okay, we want to have a really high-powered scheme, and that means that in this company number 1 should only be covered its cost of providing quality, so we'll just pay them according to this red bullet down here. If the contract will say that if you provide this quality, maybe this quality increase, then you'll be paid this amount of euro. And then you would ideally like to do the same for firm number 2 here, but they could just claim that their cost conditions are the same as firm number 1. And if they were to imitate firm number 1 and produce this lower quality level, then they could make a profit of this payment level here minus this cost level here. And so in order for the companies to actually reveal the cost type and to produce this higher quality level, you need to just not only pay them their actual cost at this level, but you need to pay them this, which is called the information rent. You need to pay them a little bit more. So a menu of contract in this case could be that you basically give some alternative contracts, which is defined by alternative qualities and alternative payment levels. So in this illustration, there'll be then 2 contracts to choose from. And if we set them up correctly, then the companies will choose these contracts so as to provide proper quality differentiation. So that's an idea of a menu. You can also have another kind of regulation where you do more like a dialogue or negotiation based regulation, where you, again, if we have quality here, you have benefits and you have cost, you could imagine that the consumers and the companies are negotiating how to share this gain from quality adjustment. Assume, for example, that the original quality was down here, and by making a quality adjustment, the consumers can get some benefit, but it will cost something for the companies, and then they will negotiate here. They'll try to identify these sort of mutually attractive changes, and there should be, because of this large difference here, there should be a possibility to do so. Now the problem might be that the company is much stronger negotiating partner than the consumers in a given area. That's one of the big problems in regulation, that the individual consumers have really little or very limited interest in actually trying to reduce the cost or put pressure on the company to reduce their cost. There's a free riding problem there. Why should I do all the effort when everyone else benefit from the reduction in prices? So there'll be an undersupply of such effort. Anyway, so assuming that the company is more powerful than the consumers, then you're likely to end up with a payment which is close to the total benefit. So basically, the only one that gains from such a contract will be the company, because they reap all the benefits of this adjustment of quality. Now, one of the things you could do now as a regulator is to put some constraints on where you're allowed to bargain. You could say, for example, that you can never choose more. You should never be able to be paid more than this blue line here, and that means that they're going to negotiate between this green bullet here and then this blue up here, and then one can put this into a bargaining model, and one can show that then they will definitely undersupply the quality. They're going to move to quality level a little bit further down, and then maybe they're going to locate themselves at this very line. But that's one of the ways that you can try to introduce some kind of negotiation between the company and the consumers, and still make sure you can use benchmarking to some extent undermine the private information advantage of the company, and therefore give more power to the consumers in this negotiation between consumers and firms. So that's it. If you want to speculate a little bit before continuing, you can try to think about these questions here, give examples of different regulations in different countries, and also examples of similar steering instruments or management techniques used inside private companies. Actually, you'll see a lot of the same kind of performance-based payment schemes taking place inside private companies. But I want to just make a few observations about the benchmarking that is being used. As I said, these regulators are normally using DEA and stochastic frontiers. We already talked in pre-presentation about the advantage of doing so. If there's a lot of noise in the data, the SFA has some advantages because it's better at separating noise from inefficiency. If the big problem is that you don't really know what the technology look like, so there's would like to have a very flexible mean structure, then the DEA might be a better choice. And to protect everyone, maybe it's a good idea to do both a DEA and a stochastic frontier and take the best of those, as we talked about. Or one could also use some of the newer methods we're going to talk about in a later presentation, like the Stone method or some non-parametric SFA model. The idea is, as always in these model-based benchmarking, that you try to think of a firm, the transmission company or the distribution company, as transforming multiple inputs into multiple outputs. And then you try to account for all the complicating factors, all the exogenous factors that impact this transformation. Just to give you an idea of what these models look like in a regulatory context, I put in the first models we did back in 2001 in Sweden. So you see here that you have like a short run model where you just have operating expenses, and then you had 5 different outputs, one being peak load, which is a measure of the capacity of the network. You need to pay for that, of course, and then the number of connections at the high voltage and low voltage level, and then the number of the amount of delivered electricity at high voltage and at low voltage. So this is the amount of energy being transported. And then we had some exogenous factors having to do with we experimented with climate zones. We did something about the nature of the network by looking at stations per installed megawatt hours, megawatt. And then we also looked at something about the size of the network. We also had like a more long run model where we included not only operating expenses, but also capital expenses. And we also assumed that maybe in the long run, you can reinforce your network so that you have fewer network losses. So we had a more detailed description on the cost side here in the long run model. So that was an early attempt to do that, to illustrate what one of the sort of the larger models that are being used. I can mention the German model for electricity networks, it uses 2 types of Totex, total expenditure, one based on accounting capital cost, and another one based on standardized capital cost. I'll return to that later in this presentation, actually. But so you have sort of 2 cost measures. Use either one or the other. You don't use them to, of course, they are just 2 ways of measuring Totex. And then on the output side, we have in this German model, we had in 2008, we had 11, I think, cost drivers. So again, it's a question of connections. How many connections how many consumers are connected at high voltage, middle voltage, and lower voltage. It's Hochspannung, Mittelspannung, Niederspannung, these abbreviations here. You have something about the structure of the net. How many underground cables do you have? How many overhead lines do you have at different voltage levels also? And then you have something about peak load again at the transformation levels. So what's the peak load? Something about the size of the area that is being supplied, something about substations, and then there's also a variable that are trying to capture the extra cost of having decentralized production being connected to your network. So that's like the German model. It has been, we've done it 3 times, 4 times actually, but it's been in operation 3 times, and it's looking more or less the same. It varies a little bit from year to year, but this basic form has actually proven to be quite stable. So we're capturing more or less the same thing in the over the years. A more recent attempt to make a model is the ANEL, the Brazilian regulators model. Here is again only Opex, so operating expenses, Totex, capital expenses is ignored. And then you have some physical assets, namely underground lines, overhead lines, and some high voltage lines. And then you have something about the this average mercado, that's basically the amount of electricity being transported. So like the megawatt hours in the Swedish model. You have again the number of connections, so in this case the number of consumers, and then you have a couple of quality indicators in the Brazilian model, or which is like an environmental variable, you can also say, and that has to do with non-technical losses. In any network, there'll be some losses due to electrical resistance, but and that's to a large extent unavoidable. But what happens in Brazil is also that there's some non-technical losses, which is basically that in some areas electricity is stolen from the network. And there's also something about interruption as a negative output. So both of these are kind of negative outputs. Another feature with it, the Brazilian model, is that they have actually introduced weight restrictions. So they have a lot of restrictions about the rate of substitution at the frontier. So they give some intervals in which the relative prices of underground to overhead, or the relative cost of operating underground to overhead lines, what could be the relative cost of that? So they say, for example, here that underground lines can be at the most twice as expensive as the overhead lines, and it is at least as expensive as the overhead lines are. So that's the Brazilian model. Here's another exercise you could think about. So should you have the size of the network as an output? Is that really a cost driver? It's actually something that you decide to a large extent yourself as a network company. So it's like an endogenous variable, you can say. You can also discuss whether interruptions, blackouts, is that an input or an output? You can also try to think about, does the firm like to have weight restrictions in the models? You can ask yourself, does the firm like to have many comparators, a few? Or do they like to have many outputs or a few outputs? So that's worthwhile to think about, and we can discuss that during the questions. But now it's time for the break, and I'm going to stop the first part of this this presentation on regulatory benchmarking, and we can take some questions.